hackers and tinkers, and welcome back to the Northern Ireland Raspberry Jam Live. This month, we have a number of cybersecurity related activities for you to get and try out and all lined up, and we can't wait for you to start. Once again, we'd like to thank Nitech Solutions Limited for letting us use their building, and more specifically, letting us use this really cool workshop and office space for this month's jam. Lined up for today is 2 workshops as well as an interview with Dean, who works on an industry-level piece of software called Metasploit, or called the Metasploit project. Firstly, though, we'll be joined by James Matchett, who will be teaching you all about how websites store your login details and how to keep them secure from hackers, and all about password hashing. After that, we'll have a short break to let you stretch your legs, get some water, the whole bonanza, followed up by the second workshop on how to steal a pizza by the Cyber Skills Live team. Finishing up will be the interview with Dean, who will be interviewed by Abby, who by chance is his sister, about his experience in the cybersecurity industry. If you have any issues at all or any questions for myself or the team, feel free to pop them into the live chat and a member of the team will be able to help you out. For now though, let's get started with Alphabet Soup. So, James, do you want to give yourself a little bit of an introduction?
This exploit is going to be a bit of a workshop on how websites store your password. And it may be slightly surprising. You might think it's very simple. It takes your password when you type it in and just checks to see if it's the same thing. But the answer is a little bit more complex than that. My name is James Matchett, and I'm a cybersecurity engineer for Kainos. My day-to-day job involves testing systems to make sure they're fully secure. And hopefully in this workshop today, I'll be able to show you how you can start looking at systems and teasing them apart. So Sam, if you're ready to get started?
Let's go.
Perfect. Hopefully everyone can have access to the REPL link that's been posted in the chat. So we're going to start off in the README file.
So to get started, for the actual REPL introduction, the link in chat will allow you to log in and get an account set up so you can access the actual projects and different files that have been set up for you. Essentially, the link in the chat will be a REPL.it and then a big long URL. Click that. You'll be presented with a login asking for a username and a password. And whenever you've gotten that, all you need to do, keep the default username, but make sure if you want us to help you, you remember that username. It'll be the top left-hand corner. Post it in the chat so we can find out who you are. And make up a really secure password. It would be very ironic to not use a secure password. So put a secure password in. If you forget it, you've only lost your work, but it's only for this workshop, so no biggie. And once you've done that, you'll be presented with all the projects that you can get. Whenever that's done, click view and you should see Alphabet Soup. So
Alphabet Stew,
and you should hit start assignment or something similar to that, and that'll bring you up into the code. Once you're in the README, click the wee main.py file and we'll get started. But we'll give them about 30 seconds just to get kicked in and make sure they're all ready. Perfect. But then your experience though in password hashing.
Yes, I've used it quite a lot on various projects, and thankfully it's not something that you actually see is not implemented properly these days, but it's one of those things that you always have to check that you get right. Every day we do see that there's stories about passwords being leaked out there on the internet, and it's because the developers making those systems just haven't followed the rules. And that's what we'll be covering today. What are the right way to do things when it comes to storing passwords?
Perfect.
I see someone's just asking for the link in the chat. I'm not sure if it's been posted there.
Just in case.
We have another 30 seconds just to get all set up.
Yep. Size up and ready.
Perfect. And if it's okay, could we have the main screen just shared? Just so everyone knows what they should see whenever they get signed in. Ready to start? If anyone isn't ready to start, please just say in the chat if you're having any difficulties. But Sam, if you're ready to start, we'll crack on.
Is that on?
Perfect. So just at the very top here, we're going to be looking at our readme.md file. It's on the left-hand side here, just when you get signed in. And this is going to be the guide to walk us through the entire workshop. And just at the very top here, oh, I'm hearing myself twice. I'm hearing myself twice. Is someone else not muted? Okay, I think that's all sorted now. Apologies. I could hear myself twice there. We're going to go through the introduction here, and this is going to be looking at the world of password hashing. And your first question probably is, what is hashing, and why does it matter? We're going to look at it, what it is, how it works, why it's used, and why it's very important to use. As I've said before, my name is James Matchett, and I work as a cybersecurity engineer in real life. And this means it's my job to make sure that all the software my company writes is secure and can't be hacked by hackers. I work on many different systems, from hospitals to banks and many other things on the internet, to make sure they're completely secure. And in this workshop, we're going to look at how a hacker would try to guess your password and how they might try to dehash your password so they can use it for themselves. And this is a workshop for beginners. The only thing you'll need is a bit of practice with Python and an attitude for learning. Now, just to cover a bit of background, when you make an account on any website, you've just done it now with REPL, for example, it has to store your username and your password. And this means when you try to sign in again, it has a way of making sure that you are who you say you are. You don't want someone else to be able to steal your password and pretend to be you. The username is the who you are, but your password is what we call the authentication, or in other words, proving that you are the right person. So we have to ask, how does a website do this? And if you see this diagram on the right-hand side, whenever we type in our username and our password and click register, that then gets stored in a database. And think of a database just like a big table. It has columns and it has rows. Along the rows, we have each person, and along the columns, we have each type of data we want to store. Most databases are set up so that only a website can see the database. We don't want the entire public to be able to see what exactly is on the database. But sometimes an attacker can actually get access to the database. And that's whenever we have to think about, how can we make a website so secure that even if an attacker can get the database, that they can't use the passwords within? So we're going to move on to exercise 1 unless anyone has any questions. Nope, perfect. So the first thing we're going to do here is on the left-hand side, click on main.py. It should be right at the top on the left-hand side. And we're going to make sure that the only thing which isn't commented out is import exercise1.exercise1. The other two lines should have little hashtags in front of them. And once you've got that sorted, we're going to open up the exercise1 folder and click on exercise1.py. And we'll just give it 30 seconds to make sure everyone's got this far.
So you're saying that the databases would be holding the information, but you say that with hashing it makes it more secure. So right now, would you say that REPL will have used hashing?
Absolutely, or we'd very much hope so. If not, then they're in for a very serious conversation from me. But obviously, exercise 1 is just... Sorry, go ahead, Sam.
Oh no, obviously we wouldn't be asking people to try and see if they could get password from REPL, but as demonstration purposes.
Yep, exercise 1 is going to show you what it looks like whenever a website doesn't use hashing. We're going to pretend that our attacker, and we're going to call him Bob, has managed to hack into our website and steal our database. And we're going to see what would happen if a website decided to just store the passwords in plain text. That means they're not trying to encrypt it, they're not trying to hash it, they're just storing it as you type it. And we're going to see why this is a really bad idea.
So it's like as if a data leak has just happened, so Bob
has
acquired. Okay.
And you see this on the news all the time, definitely. Stories about companies being attacked, and there's a huge data leak of people's usernames and passwords. And we're going to try and find a way that even if a data leak happens, our passwords stay secure. So we're going to start off here. Sorry, go ahead, Sam.
The worst thing would be having the same password and then being able to find out from your email address, because, well, if you think about it, you need to be able to store the email address, isn't it? So actually check who it is. Okay, but then you'd only like hide the password, because if you hide the password, then you make sure that no one can steal it and only the person who made it knows what it is.
Definitely. And
Okay.
it's just a good way of making sure that even if our database gets leaked, first of all, an attacker can't sign into our website with that person's account. But second of all, if that person's used that email and password somewhere else, it means their accounts there will stay secure. I'm guilty of this myself in the past. I have reused the same email and password on many different sites. And that means if there was a data leak on just one of those sites, all of those different websites could have been compromised for my account. So let's carry on and just have a quick look at what exercise1.py has in its code. First of all, we have an import JSON. And if you don't know what JSON is, don't worry too much. It's just a nice little way of storing some information. We have one method up here at the top called view records. And this is where we're going to have a quick look at the data that our evil hacker Bob has managed to steal from a website. All it does is it loads in the data and it loops around 5 times to try and see what data is in there, and we're going to print it out. We have a second method down here for checking a password, and we're going to look at that in just a wee second. The only thing you'll have to do right now is right at the bottom, make sure that the method call for view records on line 26 isn't commented out, and that check password is commented out with a little hash in front. It should turn green whenever. And if you click run, you should hopefully see 5 records be printed out on the right hand side. I'm going to give everyone 30 seconds just to make sure they've got that working. If you have any issues, say in chat and we'll try to help you out as much as we can.
So out of interest, what does like putting a hashtag in front of the code mean? Like what does it do?
So that's called a comment. And sometimes developers will use it to earmark their code. So I could put in small comments saying this prints records. If I could type, that would be lovely.
But then is that code like obviously there's no errors when you write that. It's not actually valid code though.
Definitely. That little hash just tells the computer to ignore this line, not to try and run it as code. And this means if we do have code we don't want to run, we can put a little hash at the start of the line and the computer will just ignore it for the time being until we take that little hash out.
So all we're doing now is to make sure that we only run the view records function,
Definitely.
and then that will like look at the file, load it in, and then just kind of spit out 5 rows, is it? Or how many
5 rows it
5
is,
rows.
yes, exactly. So what we'll see here on the right hand side is 5 rows from the database that our evil hacker Bob has managed to pull out. Now, if anyone isn't seeing this, make sure that in your main.py file, the only thing that is uncommented is the first line for exercise 1. The other 2 lines should be commented. Hopefully everyone's managed to see that. So let's have a quick closer look at the information pulled out of the database. First of all, we can see someone's balance, their profile picture, their age, their eye color even. This is a very detailed website. But the thing that we're most interested in is their email and their password. And here we can see that the database is storing it in plain text. And when I say plain text, I mean we as humans can read it and just use it straight away. We don't have to do any fancy tricks or decrypting it. We can just see what it is right away. That's what I mean by saying it's plain text. And this is a really, really bad way of storing passwords. And here's our example. Let's have a quick look at the check password method. This is going to pretend to log into the website, and we're going to try to log in with someone's username and password to see if it's valid or not. So down here, if you comment out, actually no, let's leave it uncommented. Keep view records uncommented, but also uncomment check password on the bottom here. And we're going to grab the first username and password up here at the top. You'll see it's cherry.mullen here at hinway.me. So we'll copy that and paste it into the first parameter here. And that's going to be the person's email we're going to check. And the second thing to check now is their password. So we just copy and paste that into here. And click run. We should hopefully see we've got the correct password for Cherry Mullen. Now, just to make sure that it's not a false positive, we'll type in test1234, just for an example. And we'll see it says it's the incorrect password. Why don't you give that a go on your computer, choose a few different random records, and see if you can get it to sign in.
So is this kind of like not intimidating, sorry, like replicating the idea of like you have, like REPL, you have the login box and you have the password, and then you put in your email address and your password. But in this case, because the passwords aren't hashed, we could basically just scrape that and take that information from the data that we've got and found and just plonk it straight into, well, what would be the website.
Exactly. And this is really bad because even though the attacker can sign into their account on our website straight away, as I've said before, they might have reused that password on other sites. And that means all those different accounts will have to have their passwords changed by the legitimate owner to be secure again. One little challenge I want people to try. Can you try to get more than 5 records printed out? What thing in this method would you change to get more than 5 records printed out? I'll give everyone 60 seconds to try and figure that one out. There's one thing you need to change in this method to get more records printed out from our database. Give it a go yourself. And if anyone is having any issues, feel free to pop in the chat that you are. So just in case anyone didn't get it, let's look at our view records method one more time. We're going to open the file, we're going to load the data, and here we have I is equal to 0, and that's going to be our little counter for how many records. If you go into the for loop here, you'll see we have if I is greater than or equal to 5, we stop. So to get more records printed out, we just need to change that 5 to a different number, to say 10 for example. And now we'll see 10 records printed out instead of 5, and that's how you'd get more records out of this file.
So out
Do you
of
think we're ready?
interest, what does that for loop do then? Because obviously
one here?
you've got the print, and then it like prints it so it like separates them, and then you've got it increments I by 1, like adds 1 on the end of it, so it goes 1, 2, 3, 4, 5, and then
Yep.
So it only does it that number of times. But what is the for loop for though?
This for loop here is actually go through the data file itself. It has everything split up into individual records. And this for loop just tells the computer, start at one row, do whatever, and then once you finish that, do the same thing again for the next row, all the way until you're out of rows. This little bit here, the if I is greater than or less than a number, that's just for us to exit early. If we didn't have this in, this would just print every single row in the file. And that would be very messy.
Mm-hmm. And it's very similar to like a database. So with your example with Bob, like, so it would be, you've got the name, you've got, eye colors, you said, and it would find that row in the database and just kind of spit out all the information.
Absolutely. So this little method here is just to make sure that we get some information so we know what's being stored, but not so much that it's too much noise for us to try and make sense of. I think we're ready to move on to exercise 2. So if everyone managed to get on okay with that, head back up to your main.py file right at the top. And for our first line here at the very top, exercise 1, we're going to put a hash at the very start of that line. And we're going to go for exercise 2 and take the hash off that line. So your main.py file should look like this.
Out of interest, James, very sorry to be a bit annoying, but could you zoom in a little bit?
Yes, definitely. Hopefully this makes it slightly bigger.
And then obviously with the hashtag of the commenting, I'm guessing, have we done one of the exercises? Are we going, like, is what we've just done been like an example to show off what we're gonna do?
Yep, exercise 1 is just to show how a website shouldn't store passwords. That is the bad practice, storing them in plain text. What we're going to do now is look at exercise 2 and see how a website actually does store passwords. At least they did in the 2000s. I'll show you why sometimes even just hashing itself isn't enough to keep things secure. So if you've managed to get to exercise 2 on main.py and you've uncommented that line, head across to your README file, and we're just going to do a little bit of reading before we carry on. So we've seen exercise 1. And we're going to go down to this heading here called background to hashing, just to talk about what hashing is before we continue. And as I've said before, hashing is a way for us to store data in such a way that we can still check if someone's password is correct, but that evil hackers who steal our database can't use it to steal when they log in. They can't use the data that they've stolen to log into someone else's account. And in hashing, we take our plain text password that we got from exercise 1, and we get a jumble of noise out the other side. So here in this diagram, we see we put Fox in, we run it through this hashing process, and we get a jumble of noise out the other end. And you see here, if we choose a different input and put it through the same function, we get a different output. And the important thing to remember here is, if I put Fox in twice, I'd get the same output twice. Hashing is very precise in the way that you get the same output from the same input. Now, the best way I like to think about hashing is like a washing machine. We put nice, ordered letters and words in, and we get jumbles of noise out. For example, if I put my super secret password into a hash function, I'd get this big jumble of noise out the other end. And here's a really neat thing. It's really easy for a computer to do as forwards. Very easy for it to turn my secret password into that noise. But it's really, really, really difficult for a computer to take that bit of noise and move it backwards to my super secret password. So much so, you don't... Oh, pardon me. No idea what happened there. There we are. I might need to grab a drink in just a minute if that's alright.
It's no problem.
Oh, sorry about that, folks. You might even say that it's impossible for it to go backwards. Sam, can I take 2 seconds just to grab a drink if that's okay?
No problem.
Sorry about that, folks. I'll just be back in just a second.
It's interesting because in the case that you've got the code and you've got something that you like as text, you want to have it in some way, shape, or form just transformed into, well, as James said, it's noise. So you're not able to look at it and understand what it is because you can't understand this means fox. So it is quite useful for computers. Computers can understand this. Not a problem for them. They can't take fox from that what's been output from the hash, but they can rehash like fox again, and it'll always come out as that. And thankfully, for any attackers, they can't do much with that. There's a couple of techniques that they can use, which I know James will go into shortly, but essentially it's putting it into such a way that it's not readable by us, no way, means, form, but other computers can. So this is secure to an extent, and there are different methods that you can use to make it even more secure. But for the most part, well, I don't think any of you would be able to reverse that, unfortunately. So I think that's quite secure in itself.
Sorry, that's me back. Apologies about that.
No problem.
So, as I'm sure Sam was saying, it's nearly impossible for a computer to actually make a hash go in reverse. Which means if we store the hashed password instead of the plain text password, as in we store this bit instead of that bit, our evil hacker Bob can't work out what the password is. So how does this help us? You might be asking, well, it's great if we store the random noise from hashing, but if we store the hash instead of the password, how do we know when a user tries to sign in that they've used the right password instead of the wrong one? And here's where the really neat trick comes in. Whenever a user signs up to register an account for the first time, we check their password to make sure it's strong enough, we hash it to get that noise, and then we store that hash. And then whenever a user comes back to try to sign in again, we do the same process again. We take their plain text password they just typed, we hash it, and then we see if that hash matches the one from before. And because the hashing process is so precise that the same input will arrive at the same output, it means we can check very, very easily if they've used the right password or the wrong password.
So what you're saying is that if I, for example, my username was Sam, and I were to be logging into my favorite banking account.com, and I were to put username Sam, and I were to put Fox, which is not a secure password, don't use Fox in any way, shape, or form, please. If I were to put Fox in as my password, for example, it would come out with that hash, and that hash would then be taken by the bank, by the code in the bank's website, and said, I'm going to keep this and lock it away in a database. And whenever I'm actually to log in again, what's done is, whenever I put my username, it knows it's me, and then it says, okay, Sam's trying to log in, what's he actually put down as password? Pulls that, me typing Fox in again, and hashes it, and if they're the correct or the same, that gives it basically a thumbs up, and then lets me log in.
Absolutely. And it's basically doing it in such a way that only you know your password. And it might sound weird to say, but websites don't actually know your password. They store the hash of it. They don't store your password. They store the hash of it. And it means when you try to sign in, they just do that process one more time where they hash it and check if the two hashes match. And that's how it knows if you've typed the right password or the wrong password.
Does anything go wrong if I put in the wrong password, or what happens usually?
So if you put in the wrong password, the hash you get out from the other end wouldn't match the one that you put in whenever you set up your password for the first time. And
Okay.
because they don't match, the website knows you didn't type the right password.
Hmm. And then obviously that would say you've put in the wrong password, like you're not Sam. But obviously I could be Sam, just like put in the wrong password accidentally.
Exactly, exactly. So let's carry on with exercise 2. And as I said before, if you go up to your main.py file up here at the top, and make sure that exercise 2 is uncommented, and the other two lines are commented with a little hash at the start. And then finally, we're going to go down to the exercise 2 folder, and we're going to start with exercise2.py. And we're going to check how an attacker might try to break hashing.
Oh, James, I think your mic's gone off, unfortunately.
Um, can you hear me?
Yeah, I can. No, I can.
I thought my sound is coming via what you're hearing me through.
Mm-hmm.
Hopefully people can hear me. If not, do say and I'll try to fix it. Perfect. So if everyone's got this far, we're going to have another look at our few records in exercise 2. And this is going to be the example of a website which has stored its passwords using hashing. So if you run this, hopefully you should be able to see on the right hand side 5 records of people that have stored their password on this more secure site. And you'll see here, instead of having a password this time, we're storing the hash. Hopefully everyone's able to see that. I'll just give everyone 30 seconds to run this themselves and see if they can get the hash out. If you give me a little thumbs up in the YouTube chat, that would be perfect, just so I know everyone's getting on okay.
So it's essentially the difference between this and the other one, just that the hashes came out and, well, they're all the same length and they all have, well, no, sorry, they're not all the same length. No, they are all the same length. It's
They're
just
roughly the
different.
same length, yeah.
Mm-hmm. And then all of them are just kind of, well, stored just like the password would have been, just they're not the actual password anymore.
Exactly. And it means we, as an attacker, stealing the database, we can't see their password anymore. We can't take that password to try and sign in again. Meaning, it's a lot more secure. An attacker can't just lift the database and try to sign in. They have to do a process where they try to break the hash. And we're going to talk about how an attacker might even try to break this. This isn't 100% immune. So we're going to scroll down to exercise 2 in the worksheet in the README file. So you just click on Markdown on the right hand side. You can keep exercise2.py open, but you'll need to scroll down on the Markdown tab to exercise 2. Just down to here. So this is going to be how an attacker could try to break hashing. Even though it's a really, really, really good system, it's not 100% foolproof. This is where an attacker can try to use brute force to guess the password. Now, we as hackers, we know the process that the guys making the website used to hash the password. So all we have to do is guess a bunch of passwords, hash them, and see if the hash matches what we got. Because the website tries to see if the hash matches to see if the user's got the right password. And we're going to do the exact same thing. We're going to guess a bunch of passwords. We're going to see if the hash that we get from that password matches. And if it does match, we know we've got the right password.
Out of interest, James.
Yes.
Very sorry to interrupt. Why, like, you say lots about hashing, and out of interest, is there like one type of hashing, or like how does like, there's obviously hashing that we're using in this, but is there like different levels or different amounts, or like can we like make a really
Absolutely.
big hash or a really small hash?
Definitely. There's different types of hashing. There's different things called hashing algorithms. And these are the different ways that computers try to hash any bit of information. And this means that some are inherently more secure than others. In the past, we used hashing algorithms that we thought were secure, but turned out they were actually very easy to go in reverse. A really strong hashing algorithm has two characteristics. The first is it's really, really difficult to go backwards from the hash to the plain text. But the second is something called collisions. And this is something where if we hash the word fox, for example, we expect one output. But if we hash the word apple, we expect a different output. If you use a hashing algorithm that gave the same output for both fox and for apple, that's what's called a collision. And those are inherently less secure because the way that it tests to see if you got the right password is to check if the hashes match. And this means someone could really choose a word that isn't your password, and if it came out as the same answer as your actual password after being hashed, the website couldn't tell if it was the right password or not. It would just say that it is and let you sign in. So that's why we use something called SHA-256. It's one of the most secure hashing algorithms that there are to be used. Hopefully that makes sense.
And then, out of interest, like there's a lot of talk about this military grade encryption. Does that actually mean anything anymore? It's just
Sometimes does. If you use weak encryption, it means that someone with not too powerful a computer can work backwards. But it's important to make a distinction between encryption and hashing. Encryption is where we sign something with a key so that it can then later be unlocked and put back into plain text. You know, encryption and decryption. Whereas hashing is described as a one-way process, as in it's easy to do one way, as in take your password and move it to a hash, but very, very difficult to get from the hash back to the password.
so you'd never encrypt your passwords. You just
Never encrypt your password because all it would take would be the decryption key to be leaked, and suddenly you could move backwards and get everyone's password. So we're going to carry on with exercise 2 here. And just at the very top here, we're going to add these two imports from hashlib import SHA-256 and from time import sleep. If you've got a version that already has one of these imports, you don't need to do it twice. You just need to have one of each, if that makes sense. And there we are. So we're going to add that right to the top of our exercise2.py. So now we're going to make a new method called getData, and this is going to load our data in for us. Now you can either type this yourself, but it would be a bit faster if you can copy and paste it. It's entirely up to you. If you want to get practice typing Python, absolutely feel free. If not, feel free to copy and paste it in just to near the bottom of your code. Just above view records, but below the check password method. And feel free to add a few lines just for spacing. And we're going to do the exact same thing with the second here called getWordList. And I'll talk about what these do in just a little second. So hopefully your code should look like this.
So where did you get that again?
So this is in the exercise 2 section of the worksheet. Just if in the right hand side you click on Markdown, you can see the worksheet here. And I'll give everyone a few seconds just to catch up. I'm just being quite conscious of time, sorry. Just we have a few minutes left, yeah?
About 15.
15, perfect. We'll get everything finished then. So if everyone's pasted those two things in, we're going to do one last thing, which is making a new method called brute force password. Now you're probably wondering, what on earth did you just paste into your code? And I'll walk through that just now. The first one is a method called getData, and this is just going to load our data in from the website. It's the same as view records, except it just returns the data to be used later. The second one is called getWordList, and this is just going to be a list of all different passwords someone might have used on a website. And we'll talk about why this is useful in just a second. So if we continue on here, we're going to add another few bits of code here, just at the bottom. And this one is for word to try and word list data. So we're going to try every single word in our password list to try and guess what someone's password is. We're going to try and hash that ourselves to get an answer. And now we've got an answer, a hash. We're going to see if it exists in the database to see if it matches.
So the way that you've done this is you don't know the password, obviously, but you have a big, massive, just dictionary full of words, and you're going to say, just similar to how someone signing up would do it, they would put in their password, and then it would get hashed, and it would be stored. We're just going to do that, but we're just going to, spam a bunch of different words that we can get our hands on, and then just keep checking which ones, as if we're trying to log in.
Exactly. So this is just, it's the same as us trying to, guess every password when trying to sign into the website, except instead of going on the website, we're then going to do this on our data that we've stolen. And this means the bank can't tell that we're trying every single password. If we were to try this on their website, they could see right away that one computer is trying to sign in thousands of accounts, one after the other. But because we've stolen the data, we can just do this on our machine without the bank ever knowing. So hopefully everyone has got this all pasted in. And our final bit here is just to go over, once we've tested the password and hashed it, we're going to go over every single user in our database we've stolen. And we're going to check if the hash matches or not. And if the hash does match, then we know we've used the right password in the first place to get the same hash. So the last thing to add right at the bottom is to call this method here, brute force password. Now, as always, you can always come back and view this code later. If it doesn't make complete sense to you, don't worry. I'm more than happy to explain anything that you're stuck on. But you can always come back later to see, what does this line of code do or what does this method do? But if you've pasted that in, you can comment out view records, and we're going to call brute force password. I think REPL's just gone down for me, unfortunately. Can you still hear me? Oh, there we are. We're back on.
Mm-hmm.
Perfect. So if we click run, we'll see this now where it's actually guessing these passwords from that word list. And we just start seeing these passwords spit out here. If everyone's able to run that, you should hopefully see this. And each one of these are passwords. Oh, I see someone saying the screen share looks a bit weird. That'll be the OBS Ninja. If someone on the back end can check it's coming through, okay? Oh, it's okay now. It must have just been buffering. So if everyone's able to get this far, you should be able to see the passwords being spit out. So let's try and guess one of these passwords. We're going to use the same check password method from before. So we just need to type in check password, and we're going to test someone's username. There. And someone's password. There. Simple as that. Or it's just skip for me. I'm going to choose someone else's one that I actually have on screen. You can choose anyone's password and anyone's username. They just have to be the same account on the same line. And now, if we run check password, we'll comment out brute force password just for now. And we should hopefully see we've got the correct password. If we choose, if we make it the wrong password by adding some random characters, we'll see it says it's the incorrect password because the hashes don't match anymore. Give everyone a few seconds just to try that for themselves. In case anyone did get stuck, there should be a copy of the code for brute force password just at the bottom of exercise 2. And if someone could just put a thumbs up in chat to say they've got that working, that would be perfect.
So obviously, from our word list, we don't have like every word in existence, and for most
Absolutely.
passwords, you have like password managers that would just give a big massive garble of just letters and numbers, and that would be their password. So how long could or do you think how long could an average password actually take? Because, well, my cat is called Sam would be a lot easier to guess than exclamation mark, 60 different characters, and then I don't know, hashtag on the end.
Absolutely. And this is why people always say choose a strong password, because the only way to try and work out from a hash what the password is to guess everything until the hash matches. If you really are curious, look at the word list file in exercise 2, and you can see some of the words that have been put in here. Now, less than 1% of the entries here actually are a password for this exercise, but in real life, password lists can be upwards of half a terabyte, and those are just the small ones. Sometimes you get things which don't even store them, they just calculate by going off the English dictionary and changing characters wherever to see if they can get a possible match. So it really is dependent on how easy is your password to guess. See, someone's put a thumbs up in the chat that they've got this working okay, so I'll just talk about salting. We may not have time to go to exercise 3 just because we have a few minutes left, but we'll talk about salting and hopefully we can get to exercise 3. But if not, we'll give you some lovely background on it. So hopping back to our README file here. Just give me 1 wee second for it to load. So you might have noticed that if you guess someone's password, there might have been a couple with the same hash, and we'll see why that is in a second. It's just disappeared for me. Just 1 second.
So why would they have had the same hash out of interest?
Well, I'll leave the folks at home to have a very quick guess as to why they might have the same hash for different users. If I run this now, we'll see this coming out here. Here we have 2 people with the exact same hash, and if you look on the line above, you'll see they actually have the same password. And this is really dangerous because if they have the same password and the attacker finds the same hash, that means they can find every single appearance of that hash in a database. And it means they don't have to work out that password for those users all over again. As soon as they find it for one person, they found that hash for every single other user with the same password. And this is why it's really important to choose a password which is unique to you, because it stops an attacker having a very, very easy way to find multiple accounts with just one operation. This means that if you happen to use the same password as someone else, it's so much easier for an attacker to find your password. Because once they guess someone else's password which happens to be the same as yours, they also have your password. And this is because hashes are so precise in the way that if you use the same input, you get the same output. Now, there needs to be a better way of storing passwords. We don't want an attacker to work out 50 people's password just by guessing one person's password. So let's try and find a way to store passwords in such a way that even if they are the same as someone else's, the hash is different. We're going to introduce a concept called salts. Not the type you put on your food, but a salt is a way of making sure that if 2 people use the same password, they'll get different hashes. And that sounds impossible, but it is very, very simple in concept. When a new user enters their password for the first time, we're going to change their password in a very, very slight way by adding something to the end of it. We're going to call this little bit of random text a salt. And that means whenever we hash that random bit, we're going to get a different hash because the password one is different. I had a diagram somewhere, but I'm not too sure where it's gone. I think it's just nipped off the screen there. 1 wee second, I'm just going to grab a diagram that I used yesterday.
So out of interest as well, actually, just as a joke, if you have a salt, is there a pepper by chance?
There is not, unfortunately.
Well,
But if I invent some brand new way of storing passwords, I will call it pepper in honor of you. So we can see here that whenever someone types in their password, we're going to add a little bit of random text. In this case, it's S4LT, but this can be any random bit of text. And because this is different than just the password itself, it means the hash we get out the other end is different. So hopefully we have time just to finish off exercise 3. The only thing people need to do is head to main.py, and same thing as before, comment out line 2 and uncomment line 3. And next we're going to head down to exercise 3.py. And it's just going to be a very, very, very quick way of just going through how did an attacker try to break someone's password, even if it is hashed and salted. Now, we have all of the code here from before. This is just workshop 2 again, but very slightly changed to deal with salts on top of it. So all you need to do is scroll to the bottom, and we're going to add a tiny bit of code. Now, if you want to uncomment few records and run that, we'll see how the data is different this time around. You'll see here, despite having a salt, there's an additional field called, despite having a hash, there's an additional field called a salt. And this is what's actually added to the end of the password to make sure it gets a different hash than if it was just a password by itself. So this means every time we try to guess a user's password, we're going to have to add that salt onto the end of it before we hash it as an attacker. And this means even if we manage to guess one user's password, we wouldn't have been able to guess every other user in the database. We would have wasted a lot of computational effort getting one person's password instead of potentially thousands of people's passwords. And this makes it so much harder for an attacker to compromise a user, even if the database gets stolen. So let's carry on with the worksheet here. And we're going to add a new method called brute force password with salt. And just as before, we're going to add our two data getters, word list data and our data from the user and database we've stolen. And finally, we're going to change it very slightly from exercise 2. Instead of trying every word and then going over every user, we've now got to try every word and then every user and then grab that salt. Just to say this should all be indented underneath brute force password with salt. And finally, once we've grabbed our word and we've grabbed a user record and grabbed their salt, we're going to add their salt to their password. The word that we're going to try and guess is their password, sorry. We're going to hash it and see if the hash matches as before. And if it does match, it'll get printed out saying it does match. But if it doesn't, then we just don't know their password. We're stumped as attackers. Once you've pasted that all in, the last thing we've got to do here is just call that method. And if you do get stuck, the entire code is down there at the bottom of exercise 3.
So, in essence, what's happened is we've obviously said, with passwords, like if I had password and, my friend James also had password as a password, like both of them would be found immediately because they'd both be the same hash. But does this add, it adds an extra piece of text, but does that not make it infinitely more confusing and more difficult for an attacker to try and, brute force and check and find to see if a password works? Because they're going to need to get the salt and then they're going to need to check it. And once they've got one, they can't find out any other ones. So
it just makes it that much harder for an attacker to compromise a whole database of people. And even if, the attacker steals the database and they guess one person's password and they manage to brute force it, it means they don't get the reward of having lots of people with the same password. Even if you share the password of someone else's account, the hashes will be different and therefore a lot much harder for people to try and break into. And if you manage to run that okay, you should hopefully see some passwords coming out the other end. So if you find one, you may have noticed that as we go through the exercises, we find less and less people's usernames. And this is because the challenges that attackers have to jump through to get someone's password get more and more difficult, and we get less and less successful password guesses as a result. So we've got a few here. I think we've got 3. And we're going to do the same things before with check password, just to check if we do actually have a user or not. Mm-hmm. So I'm going to choose Rosemary here. And I'm going to grab the guest password of Robus Kirby.
My favorite.
Oh. Incorrect password. Did I copy that wrong? I've included the salt in it, oddly enough. Very weird. My mistake. That's just a slight mistake on my part. Hopefully if we run that, it should tell us the right person. Oh, she must have a 7 on the end of her password, I believe. Alright, I've pasted the salt out at the same time, oddly enough. Yep. Very secure password.
And obviously we don't need to type in the salts. Perfect.
Yeah. Correct password. So obviously whenever you type your password in, you don't include the salt.
Mm-hmm.
The person you're logging into does that for you to make it more secure. And just as before, it stores your hash and your salt. so it's able to check that it's you whenever you sign in again. Unfortunately, that's all the time we had scheduled for this one. But just to close off everything, some closing notes. Never, ever store your passwords in plain text. I implore you, please do not. It is a guaranteed way of having something bad happen. Always choose a strong, complex password so that an attacker's word list can't guess it. And always salt your hashes so that even if someone has the same password as you, an attacker has to do that much more work to get to you. Thanks very much for your time, folks. And if you have any questions, absolutely feel free to message in.
Dead on. Well, James, very interesting workshop. Obviously for hashing and salting, sorry. It's very different, has changed across the years and gotten more and more secure, thankfully. So, thank you, James, for that workshop on passwords and hashing. Hopefully that gave you, all the viewers, some insight into the security that takes place when logging into different services and onto different websites like your bank. For now, though, we're going to take a 10-minute break to give you a breather, to stretch your legs, and to go get some water as well, just to make sure you stay all hydrated in that good weather. But don't worry, we still have loads of things lined up for you, and they'll be kicking off shortly. Again, any issues, or if you need any help with anything, drop a message into the chat, let us know, and myself or the team will help you out. But for now, though, we will let you have a nice breather. Welcome back. Hopefully you had a great, well-earned break and you are back and ready for some more tinkering. Lined up next is the How to Steal a Pizza workshop by Craig and Daniel. They're part of a team of people who run workshops all across Scotland based on different cybersecurity skills that would be and have an amazing range of workshops for you to explore. For those who have an Eventbrite ticket, you'll receive an email and a couple of details around this, and there'll be details following on from this on how to use and get onto their actual workshops on their website. But anyway, it's time for some pizza.
Hello, good afternoon. Welcome to this bonus Raspberry Jam Cyber Skills Live. So this is the first time we've run one of our activities in Northern Ireland, so welcome, thanks for joining us. My name's Daniel, I'm an engineer. I'm interested in all things tech and security. And you're about to get hands-on in the next like half an hour or so and learn cybersecurity skills in this sort of interactive activity. Our digital world's powered by technology, from exchanging messages to turning on the lights. We rely on tech every day without realising the impact that it has on our lives sometimes, and it's really important that we protect it properly. I'm coming to you from my top secret pizzeria somewhere in Edinburgh, and I'm here with Craig. So hey Craig, do you want to introduce yourself?
Hello, I'm Craig. I'm a computer scientist, I'm a gadget geek, and I'm interested in all things tech. So you're in a top secret pizza location in Edinburgh, Daniel. I'm in a top secret pizza location in Glasgow. And today, everyone who's joining us, you're going to get the chance to try out some ethical hacking skills. So to take part in the activity this afternoon, you need to go to cyberskillslesson.com and you need to click the button that says Start the Live Lesson. While you're playing along today, so we're on YouTube live, you can send us a message. You can tell it's live because I make a mistake when I'm talking. You can send us a message in the chat. We'll keep our eyes out for that. Or you can tweet us using the hashtag CyberSkillsLive. So as I said, Daniel, are you ready today to become an ethical hacker?
I'm definitely ready. So let's roll our intro video.
Nowadays, many shops and companies rely on technology to run their business.
From taking customer orders online, to emailing suppliers, to dealing with other businesses.
We need more cybersecurity specialists to help defend against cyber criminals.
In this interactive lesson, you'll step into the shoes of a cybersecurity consultant and help a business test their website security.
Your client is Auld Lang Slice, a pizza restaurant in Prestwick. They're about to launch a new website that lets customers make orders online.
And they've asked us to form an investigation of their website to help spot security issues.
First, you'll investigate the public-facing side of the website. You'll gather intelligence to create a report about the security of their website.
Then, you'll investigate the software and tools the website is using. This will help build up an even better idea of where they might need to improve their security.
Finally, using the intelligence you've gathered, you'll try and find a security vulnerability and use it to break the website.
Auld Lang Slice is a fictional pizza company, so you won't actually be breaking or stealing anything, but it will give you an insight into how businesses can protect themselves online from cyber attacks.
Now it's time to start security testing. Follow the instructions and let's see how many security vulnerabilities you can find.
So we've been asked by Auld Lang Slice to carry out a security assessment or a penetration test on their website. And we're going to come back to those terms in just a bit. But what you need to do now is go to cyberskillslesson.com and then choose how to steal a pizza and then click to start the activity.
So our goal this afternoon is for you to try and find as many security flaws with Auld Lang Slice's website. So we should point out today, Daniel, we're not actually hacking a real company. This is an educational website that we've set up as well. So don't worry, none of the stuff that you're doing today is going to damage anything or is going to break anything. Our goal is to try and find as many security issues as we can and collect them into a report. So you're going to be shown a series of questions, and to answer them, you'll need to investigate the Auld Lang Slice website. So what you need to do is you need to make sure you're on cyberskillslesson.com, and you're going to check the how to steal a pizza, and you're going to start working through the activity. And while you work through the activity, you need to have open the Cyber Skills Live website. So there's a button on the front page, that on the front part of the activity, that will open that website for you. So you need to keep the Auld Lang Slice website open in one tab and the reporting tool in the other.
So this kind of security test that we're doing this afternoon, it's called a passive attack. So we're just gathering intelligence or information rather than trying to actively break in directly. And sometimes people call this open source intelligence gathering, but basically what that means is we're looking at what's open for everyone to see. We're not trying to interact with the website, we're not trying to hack it, we're just taking a look. So this is normally the first step in any security test. And our goal is to create a report that will tell Auld Lang Slice what problems they might have on their website. Every time you submit a piece of intelligence, we're going to see it and we're going to add it into our report.
I can already see, Daniel, people are starting to log into the report already. So thanks, Jay, for signing up. You've already got on the website. You're starting to prepare your answers. Hello, Bog, as well, who's starting to work through this activity too.
Craig, why might a company want to employ us to do one of these security tests?
Well, it's much better for an ethical hacker or a cybersecurity professional to find problems in a website and to find the security flaws rather than a cyber criminal discovering them. And sometimes companies might have set up their website in a certain way that actually has weaknesses in it or flaws. In the first workshop earlier on with James, you were finding about a really common flaw that happens in a lot of the way that people store information as well. So we need people who are ethical hackers, penetration testers, cyber security professionals to investigate and find these things before cyber criminals do as well.
Oh, I see. So a lot of the stuff I'm seeing on the website is things like telephone numbers or staff names, the business address. That all seems kind of normal to me. Like, why might these be security issues? Why are we pointing them out?
Yes, so there's a thing called social engineering, and it's something that cyber criminals do. And what basically they do is they trick people into doing stuff for them or revealing certain information, because it is much easier to break into a computer system or a website by exploiting the humans than it is to trying to break into the computers themselves, trying to hack into the machines. So let me give you an example of social engineering. So say, for example, you could tell from a website, you knew the opening times of a shop, right? So you know what time they open at and what time they close at. What might that tell you as a cyber criminal?
Well, just as a general criminal, I think if I knew a shop was closed every Monday, then I'd maybe do my break-in on a Monday. So I guess, yeah, if you knew the opening times, you might know when it's sort of unattended or when there might not be someone working on the systems.
And cyber criminals can also do other things, like they're really good at pretending to be someone that they're not. So they might pretend to be something like a manager from the shop, or they might pretend to be the technical support team. And if they learn from a website something like, who are the names of the managers of this company, then it's much easier for them to pretend to be that person. You know, they can work out, you know, they could phone up someone and say, oh, hi, it's Daniel here. I'm the manager of this place. Can you tell me? And then they find out some more information. Or they do what's called spoofing, where they spoof the telephone number to make it look as if it's a call maybe coming from their technical support team, but actually it could be a call coming from the cyber criminals.
Well, just kind of on that note, Craig, I can see that Jonathan's managed to find out the name of the general manager, and Bog has found out the number of the customer care team. So maybe putting the two of those together, you could do some of that social engineering that you were talking about there. Like spoofing, pretending to be someone new from, say, the customer care team, which might be off-site, and then trying to sort of speak to the managers if they already know them, or they've got a bit of background already.
Or how about the manager phoning up the customer support team and saying, oh, look, I've got a new start who's joining us tomorrow. Can you set up a new account for this, and can you set the password and tell me what it is just now so I can tell them it in the morning? So again, they might think, oh, I've spoken to James, the manager, before, then I know who that is.
Scheming.
We're getting quite a lot of answers coming in through now. I can see Jonathan and Toby has told us that the question was, what do you think is the most delicious pizza? And Toby says pineapple and ham. Not a big reaction there, Daniel.
Yeah.
Is that controversial, or?
I think the polarization of pineapple and pizzas is kind of blown out of proportion by the media. I think actually it makes sense. Like if you eat meat, it's quite a salty thing, and then the pineapple's acidic, and that's just a classic combination to have sort of the salt and the acid together, and then the fat and the cheese. So yeah, I don't think that's a controversial opinion at all. I think it sounds quite sensible.
You didn't. Well, I could tell by the fact you didn't react hugely to it.
What would be your favourite?
My favourite pizza, I like veggie pizzas, so I like Mediterranean vegetable pizza, I think would be my choice. In terms of what Old Lang Slice sell, probably something like the Garden Party pizza would be one of my choices.
Yeah, Garden Party's kind of caught my attention as well. I'd like to know what's actually on it. Like, who knows? Could be lots of stuff.
I can see that there's people who are just starting to do the activity just now. Don't worry, you have got plenty of time. Sarah, thanks for joining us. Capulet, thanks for joining us as well. What you're doing just now is sending us in intelligence, sending us in things that you've found as you search through this website and look for security problems.
Sarah, I can see you're trying to find the general manager. Have another wee look down on the About page, and you might find some more information that will help you.
I'm just having a look in the chat. Everyone seems to be happy, working through it as well. Let me just refresh this here. Well done to Sarah, who's managed to identify the most expensive pizza. Again, at this point, I suppose we don't know, Daniel, exactly like what the security flaws might be. This is the sort of reconnaissance stage, isn't it? Where I suppose we're just gathering as much intelligence as possible, and then we show it to the Old Lang Slice company, and it's up to them to decide, okay, what information are they happy to share or what do they not want to share as well.
Yeah, this step stage is just kind of a sort of familiarising ourselves with the website, but also just spotting some sort of like the obvious things that are kind of visible. So, for example, D has found the name of the company that processes the credit card transactions. So that could be some useful information if you were trying to do some social engineering. Maybe you call the customer care company saying you're coming from that card processor or something. So again, it's just useful stuff to know, because maybe WorldPay have had some cybersecurity issues of their own that we might want to let Old Lang Slice know about.
Excellent. I can see people as well working through this here. Kaylin, who's just joined, thanks for taking part. I can see you submitting your answers as well. That's great. Should we give people another 2 or 3 minutes, Daniel, just to maybe 2 more minutes before we move on to the next section?
Yeah, absolutely. In the chat, Tram Crazy said that the activity will continue in a few moments. That's absolutely fine. It means you've got to the end of this phase and you're ready for the next set of questions. So we'll open those up in just a minute's time once everyone's kind of got up to the same stage. Some people got a bit of a head start.
Daniel, let me tell you a bit more about delicious pizzas that some people have sent us in. So D has said that their favourite pizza would be Pepperoni Feast. Jonathan has agreed Pepperoni Feast. And Jay has said in all caps, Veggie Supreme. So, that's a strong vote for Veggie Supreme there. Thanks, Sarah.
Mm-hmm. Sarah's looking at the most expensive pizza. So again, just have a look at that grid of all the pizzas and see which one is the most expensive.
These answers are coming in really well here, Daniel. You can see a lot. I think we're going to be having a lot of evidence here to give to Old lang slice at the end.
Yeah, like Capulet's just found out the name of the manager. Sarah's just given us the name of the company headquarters, so we'll get that put in the report. Thank you very much.
I can see some people are still joining it. Isaac, you've just started working through the activity. Brilliant. Don't worry, you've not missed anything. You'll be able to carry on. You don't have to do all the questions. You can keep working through them as well.
Craig, I think it might be time to maybe think about moving to the next phase of our kind of
excellent
our intelligence gathering, because I can see quite a few people have kind of found everything there is to find at this stage, just on the main pages of the website.
Okay, Daniel, so tell me a bit then. We've done that sort of initial basic intelligence gathering. What do we need to do now?
Yeah, let's dig a wee bit deeper, Craig. So these next questions, they're going to get you investigating parts of the website that you wouldn't normally expect everyday users to come across to find. So it's still going to be a passive attack for now. You're not going to be breaking anything, but it's going to help us uncover some more intelligence that we can include in our report. So there'll be some new questions pop up. Just follow the instructions and keep working through them.
So this part now is going to be about inspecting, as you said, Daniel, parts of the website that you maybe wouldn't expect a normal user to be able to see. And we're going to be using some different tools as well. So one of the tools that you're going to be using is a terminal. So a terminal is a different way of interacting with a computer. So rather than using a keyboard and a mouse, then what you can do is you can just type in your, well, not rather than using a keyboard and a mouse, you're still using a keyboard, but rather than clicking on things and dragging and dropping, what you're going to do is type in your commands as well. So Daniel, in your sort of work and the stuff that you do you have to use a terminal?
Occasionally I do, yeah. A lot of tech workers have to use terminals from time to time. And there's a few different reasons for that. Sometimes it's quicker to do certain operations, like there might be a terminal command that does exactly what you want to do. So rather than going clicking on like 5 different things, you could just type in a phrase. You could even have it copied and pasted, ready to go. And sometimes also the applications that we use in security, they might be quite specialized or bespoke, or they might have been created in a hurry, like we need them super fast to help with a case. So actually, to save a lot of time, we don't bother with the user interface. So there's lots of different reasons, but absolutely it is a way that we interact with computer programs quite a lot. So it's basically you type in commands, you press enter, and then that runs the command. But don't worry if it seems a bit sort of scary or imposing. Actually, you don't need to remember all the commands off by heart. Most people just remember like maybe 10 or so, and then they'll kind of refer to books or have like a page that they copy and paste them to when they need them.
And I think that's a good idea for what you're doing today. Like, don't try and type in the commands yourself, because if you make one typing mistake, the command is not going to run. So what you're much better doing is copying and pasting the commands into the terminal. So highlighting the code, copying it, pasting it into the terminal, then hitting enter to run. I know, Daniel, that when I'm typing things into the terminal, I often make little typing mistakes like that. So it is a better idea to have something that you've kept that you can just copy and paste those little snippets of code as well.
It can sometimes be quite hard to find when you make a mistake too. Like if it's quite a long command, like it sometimes doesn't save you any time typing out yourself. So yeah, copy and paste is a good idea here. But I can see loads of you are doing really well and are managing to run the command and find some really interesting stuff. So for example, Jay has found the version of PHP. So that's software that the website uses to run. So that's a command that they've typed in and given us the version number for that.
Again, that's a good thing for us to put into security report. If we know what version of PHP the web app or the website is running, then that tells us a bit more about the technology behind it. If there's anything, maybe it's an old version of PHP, or maybe it's something that we know might have a problem with it as well. So yeah, being able to find out that information is interesting for a report.
Yeah, exactly.
What other things, Daniel?
So there's a few other things. There's some web pages, like some secret web pages that people are finding. So for example, Isaac's just found the pizza of the month for December, right? And it's obviously not December right now, but they've managed to modify the URL, the web address, to guess where you'd expect to find the pizza of the month for December, and they've managed to find out kind of what that is ahead of time.
Well, that's clearly a security problem, because if you were trying to keep that a surprise for Christmas or something, but someone could just guess the address that you were going to be putting that page on, then that could be a problem. But that type of thing happens in real life as well, Daniel.
Yeah, like I remember I think it was the iPad Air launch a few years ago. Everyone was trying to think, like, what's this going to be? Apple going to release some new product, and people were guessing like all the different names it might have. And people were putting like apple.com/blah blah 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 blah. And then someone just stumbled across like iPad Air, and then oh, lo and behold, here's the product page with all the information about this new sort of iPad that was coming out before they'd even announced it. So that was quite embarrassing, because they'd used what in hindsight was a really obvious web address, and they don't do that anymore. So basically, if we know that Auld Lang Syes are hiding information just by using like web addresses that aren't as links, people guess these all the time. So what else might be kind of visible? What else has just been hidden but not actually protected?
Yeah, exactly. We've had a few suggestions coming in as well, Daniel. There's been a part where we talk about, well, what else do you think that Auld Lang Syes could be doing to improve their website and the safety of it as well? So Capulet has said, don't give the full names of staff on the site. So, that's a trend that we see a lot at the moment. A lot of companies do tell you exactly who it is that works at that company, but that might not be something that you want to share as well. We've had another bit of advice here from Jay, which is only allow the admin login page to be accessed by certain IP addresses. Okay, so what does that mean, Daniel? What is Jay talking about here?
Yeah, so every computer that's connected to any network has something called an IP address, and it's a bit like a sort of a telephone number or a postcode, but it's a way of identifying that computer. So if you knew that, for example, the Ethernet port on the manager's desk had a certain IP address, you could limit it so only computers plugged into that socket would be able to access, say, the login page. So that's an extra kind of layer of security that companies do use. So if you have fixed desks in an office, well, that makes it much more difficult for a cyber criminal or someone who doesn't know the layout. They'd have to physically come into the building and then connect to that socket to be able to log in. So yeah, that's a really good piece of advice.
But it could be annoying as well, couldn't it? Like, what if you were the manager and you needed to log into the website, but you weren't in the office? So say we're in like the situation we are now, where you can't necessarily go to somewhere as easily, or you might not want to be somewhere, then I think that's something that improves the security. But from a usability point of view, there's a balance there, isn't it? You've got to think about that as well. Similarly, Toby has suggested there could be a sort of 3-step thing where you have to prove you're not a robot when you go to the website. So you know how these sort of captcha things where you say, oh, okay, that's a traffic light, that's a traffic light, that's a traffic light. That's really good in the way that what we'd be able to do is prevent robots or really little scripts that are being run that will automatically scan our website. That could be one way of preventing that. But why might we not want to do that on our website, Daniel, where we've got customers coming to buy stuff from us?
Yeah, well, that can sometimes be an accessibility issue as well, or it could be really annoying depending on the type of device that they use. So they've got much better now, like the ones that you just have to tick a box, because then it basically, depending on how confident it is, it's not going to make you go through lots of steps. But there's been examples on some websites. I think Ticketmaster a few years ago, they had ones that were just like, if you had like a visual impairment, you might really struggle to be able to complete that stage, and then that just means you can't use that website, you can't access the service, which is a real problem.
Even from like a business point of view as well, like if someone goes onto your website, what's the thing that they want? If someone goes onto Auld Lang Syes, they want to order a pizza, they want to get it delivered. If they're suddenly getting asked to go through security checks, they might just go, nah, I'm going to get my pizza elsewhere, and move off, potentially losing a customer there as well. So this is also why we give recommendations, but it'd be up to the business themselves, and they would have to think about, well, what is the sort of risk there? What do they want to be able to do?
Yeah, absolutely.
Tram Crazy has posted a message in the chat. From looking at the cookies on the Old Lang Slice website, they seem to be using the Laravel PHP framework.
Yeah, they are actually. That's the framework that Old Lang Slice are using at the moment. So that's some extra information. You've done some additional digging around. So yeah, cool. Well done for doing that.
Perfect. Daniel, I think we're getting a lot of good answers here as well. Some still coming in, some more questions here, and a few people have just joined. But how many, should we give it another minute or so and then we'll move on to the next part of the activity?
Yeah, let's give it another minute because I'm getting some interesting stuff coming through that I want to just do some checks before we move on, right? So
okay, you do that.
Let's take another minute, try and get through as many questions as you can, and then we can kind of finalize our report.
Sounds great.
Thanks, Sarah, for finding the SSL certificate organization. And Boggs also just found that.
I'm really impressed with how good you are at answering all these things and finding the flaws. That's great.
Just going to check and see what people have been saying recently.
One I probably want to draw to your attention, Daniel, Kaylin has posted something about the CMS, so you might want to check that.
Yeah, so that's exactly what I was just looking at here. And yeah, so what we can see here is, and lots of people are saying it, so I'm quite confident that you're all right, is that the content management system, the CMS, is something called Weber 4.1. And I've just taken a look at Weber 4.1 and it's really out of date.
I read an article about Weber 4.1 recently on Hacker News, and it was saying, I can't remember exactly, but there was a vulnerability in it, or there was something wrong with it. I know there was investigation into it.
Yeah, so it's highly vulnerable. There's quite a few weaknesses in this actually, so I think we should actually test it and see if these weaknesses are present on our system, the way that it's been set up.
So what is the weakness? What did it list it somewhere?
Yeah, so it's something called a Sql Injection Vulnerability, and what that means is you can log in without you knowing the username and the password. So you could theoretically
hang on a minute, say that again. What is this allowing people to do?
Log in without knowing the username or the password.
Well,
so
that's a pretty big vulnerability.
It's a very big vulnerability. So if it's present, it depends on how it's configured. But
okay.
If you could do that here, that would be really problematic, right? So I think we should try and trick the database into thinking we got the correct login details and have a go. Okay,
so let's see if we can do this. So what we're going to ask you to do is, Daniel was just talking there about a SQL injection attack or a SQL injection attack. So as Daniel said, this is a way that we can trick the database into running code that we just feed into it. So we're going to put some instructions on your screen just now. I want you to see if you can perform an attack on the Old Lang Slice website. So scroll down on the screen and you'll see the full instructions. So to give you an idea how you're going to do this, it's going to tell you to open up the admin page, and then you're going to go and copy and paste. Oh, there's our little avatar of people taking part. Brilliant. So you're going to go onto the page here, and you're going to copy and paste this. Oh, Daniel, are people stealing our pizzas
people are stealing pizzas already.
So you're going to type this code in, and it's going to allow you to log in, hopefully, into the website, to allow you to start getting a coupon so that you can get your pizza for free. Daniel, it looks like it's working already. I think the vulnerability's here.
I think the vulnerability is definitely there. So,
did you design this interface? Did you design this just to block me out whenever we score?
I thought people might be fed up of looking at you by this point, so the receipts are just perfectly kind of obscure your face. So
follow the instructions on the screen. Every time you steal a pizza, one of your receipts will appear in front of us, and the number of pizzas will fly across the screen as well.
So it seems a bit daft that you could do this and websites allow it, and this is a problem, but it's really common with older software such as Weber 4.1. And what you're doing is you're putting code into the username field. So it's expecting you just to type in like a name, but actually it's accepting it and it's running code that you type in there. So you're able to run code on our website, on the Old Lancs Labs website, and then use that to log in, create a coupon code, and steal a pizza. We're up to 10 pizzas, Craig.
I can see. And it's surprising because SQL injection attacks are one of the most basic things that you learn. So if you take a cybersecurity course or you work in security, one of the first things they'll teach you is how to defend a website against these types of attacks. And even though that is the case, people still do this all the time. This is something that you'll read about in reports over and over again. Sometimes, Daniel, we've seen little news articles that say things like, you know, such and such a website was involved in a highly sophisticated and organised cyber attack. And then it turns out when they look into it, it's like, okay, it was a SQL injection attack, e.g. the type of thing that you could have learned at something like a Raspberry Jam or a Coder Dojo or something like that.
Yeah, one of the oldest tricks in the book, but still, it's such an easy thing to overlook when you're creating a website that unless you actually explicitly say like, don't run this as code, treat it as just text. By default, a lot of systems won't do this, and Craig, someone's managed to automate the pizza stealing, I think.
Fantastic.
The numbers are just
what we like.
going over and over and over.
So we've got over 33 pizzas stolen now. Daniel, I'm worried about the bill.
Yeah, what size are these pizzas? They're large.
Excellent. So well done, everyone managing to get through here and steal the pizzas. Over 43 pizzas stolen so far. 136 pieces of intelligence submitted. Fantastic, Daniel.
Yeah, really good job, everyone. So like, if these are the types of things that you found and you've really enjoyed kind of finding this information, having a look around, and then it kind of builds up and then you find something that's kind of like a key clue, and then you try it, it's really satisfying. And if you also enjoy this and maybe stuff like cybersecurity, or more specifically penetration testing, might be something you want to kind of look into a bit more in terms of something at school or at university.
Absolutely. And if you want to do more of these types of activities, Daniel, so what could we do?
Well, there's a few things you could do. You could go to cyberskillslesson.com and you can see we've got about 15 different cybersecurity and data science interactive activities just like this one. We've also got a YouTube channel where we have videos from our live stream, and often we run a few of these, maybe once a month or so, run a big live online event, a bit like this, with lots of different groups taking part at the same time. So if you want to be one of 500 people, for example, taking part, then if you sign up to our mailing list, then you'll get notified whenever we're going to run one of these live events.
Brilliant. I just want to say some of the other activities that you could maybe try out on the website. If you enjoyed stealing a pizza day, why don't you try out How to Rob a Bank, which is on the page as well. So you get the chance to learn what it would take. You know, in order to defend against cyber criminals, you have to learn to think like one and use your knowledge to learn how to rob a bank. We also have an activity called How to Solve a Murder, which is a bit more about digital forensics. Daniel, is that right?
Yeah, so How to Solve Murder is a bit more about digital forensics, and it's looking at, well, what if we've collected some evidence? What are the stages that the police or a company working with the police might go through to kind of look at the evidence? But if you're also interested in digital forensics, we've got one called How to Spot a Data Leak. And data leaks are everywhere nowadays. You're always hearing about companies not securing data properly, data getting leaked out.
We saw one about 40 minutes ago.
So exactly. So that's an activity looking at it's a telecoms provider. So that's a really fun activity. It's one of my favourites.
And you don't need to take part in these live necessarily as well. So if you're watching this on YouTube at another point, or you fancy playing it later, then you can go to our website, cyberskillslesson.com. I want to see, Daniel, if we can get to like maybe, I don't know, 140 pizzas, something like that. And then we'll see if we can just wrap things up there. So we're at 127. I think we can afford a few more pizzas.
I think we can afford a few more. I can see we've got a message from Catherine on YouTube. So there should be instructions on the page, but what you have to do is you go into the login page. So with like select asterisk from users where user ID equals 105 or 1 equals 1. So that piece of code should be on your instruction page. You want to copy and paste that into the username field and then just press login. Don't put in the password. And that's going to run that code and it's get you logged in and it will take you straight to the coupon page. I think your goal was a bit under ambitious, Craig.
We've smashed it. We've smashed it. We've got plenty of pizzas. Well done, everyone. Thank you very much for taking part in today's interactive workshop as well. Over 150 pizzas. Daniel, I think the Old Lang Slice server is going to explode.
I think so too. So I think maybe we will pass back to Sam and the team in just a moment. So thank you very much for taking part. Hopefully we'll see some of you on our future streams and enjoy the rest of the Raspberry Jam.
Bye!
Bye everyone.
We'd like to thank Craig and Daniel both for taking part in this month's jam and giving you a trial and seeing how easy it is to get a pizza. And in my honest opinion, this is possibly one of the coolest ways to represent that. But to wrap things up though, for this jam, we do have an interview with Dean Welch, a previous volunteer of the Northern Ireland Raspberry Jam, and working on software that is helping keep systems that you use on a daily basis nice and secure. Funnily enough, Abby, one of our volunteers, is Dean's sister. So she took the time out to interview him and ask him about his experience in the cybersecurity industry. Over to you, Abby.
So who are you and what do you do?
I am Dean Welsh. I am your brother. You should know who I am. And I work at Rapid7 as a software engineer. I work on the Metasploit framework.
What is Metasploit?
Metasploit is an open source penetration testing framework. Open source just means that anybody can go see the code. We accept contributions from a whole range of people, and it's used by penetration testers or people who enjoy CTFs, that sort of thing. They use it for Metasploit's vast range of exploits, scanners. You name it, it's going to be in there somewhere.
What projects have you been involved with in the past?
Previous to my work on Metasploit, Rapid7, I used to help develop on the platform team, mostly working on our single sign-on solution. So you'd be able to sign in once to our platform, and you have access to all of your other Rapid7 products. But during my time at Metasploit as well, I have also helped out with a couple of our CTFs, capture the flags. Did a challenge or two for those as well.
What is capture the flag or CTFs?
CTF, capture the flag, it's a challenge. You're basically given either a system or some sort of puzzle that you have to solve in any way you can, and you're given a flag, or you attain the flag. You submit that and you get your points for the Metasploit one. Recently we usually give you we give you a Kali box and we give you a target machine, and you have to figure out what the exploits are and get the flags that way.
What is an exploit?
An exploit is a vulnerability in some piece of software or potentially hardware that allows an attacker the ability to do something that they shouldn't be able to do.
What could that be?
It could let them look through your webcam. It could let them run code on your computer. It could let them capture your keystrokes so they can get your password. Or you might have heard of ransomware, which would, it could encrypt all the files in your computer, and then they would ransom you the password to unencrypt everything.
I didn't actually know that. Who participates in a capture the flag?
Anybody that wants to. There's not usually any restrictions on who can do it. Anybody can join most capture the flags. Penetration testers might for really fun, or researchers, or just any sort of software engineer, programmer, or even if you aren't one of those, you can still join.
What got you interested in cybersecurity?
Pays well. I'm not sure. So years ago, when I started uni, I found out about Metasploit, and I installed it on my laptop. I played about with it, and it just seemed like the coolest thing. And then, that's sort of why I wanted to get into it. And then whenever the opportunity came to apply to Rapid7, I thought, hey, these guys do cybersecurity, that'd be pretty cool. It wasn't until after I had applied that I realized that they actually made Metasploit. So it just ended up working out really well for me.
What skills would you need to work in cybersecurity?
You need to be enthusiastic about it. You need to be willing to learn a lot. There's a lot of different areas in cybersecurity. It's not just one single thing. I think you'd be fine as long as you're willing to learn, as long as you like puzzles and challenges, that sort of thing. I think those are the most important things that you need. Anything else you can you can pick up.
Did you go to university and what did you study?
Yes, I went to Queen's and I studied computer science.
While you were at university, did you do anything extracurricular?
Yes, I met this guy called Andrew. Hi, Andrew, who encouraged me to join this Raspberry Jam thing. So I would do that, what was it, monthly? And I also went to a couple hackathons. There's one that Ulster Bank did, Hack Make the Bank, I think it was called. Came first place in that, where our idea was use your phone with the NFC to lift money out of an ATM. And a couple of the hackathons, I can't remember what they were for.
What would you say would be the most interesting thing you've done so far?
Honestly, it's probably towards the beginning of my working on Metasploit. Whenever I created my first exploit module, it was for some piece of software called File Sharing Wizard, and it was the exploit allowed you to get RC, remote code execution, on the target machine. It wasn't anything special, but it was the first exploit module I wrote, and that was just the coolest thing to me at the time.
How would someone who's interested in cybersecurity go along getting a job in it?
Hackathons are great. You should go to hackathons. Not only are they great to put on your CV, but they're a lot of fun, and I can't recommend them enough. Um, Also, if you can, there's lots of CTFs, capture the flags you can do online, and there's lots of resources to learn how to do them. If you check out something like Try Hack Me or Hack the Box, and they're fantastic resources to learn. Other than that, just learning programming in general is a massive help as well. Do your own personal projects. Just don't stop learning.
Is there anything else you think?
Go to conferences if you can. It hasn't been on in a while because of the whole pandemic thing, but B-Sides is a fantastic cybersecurity conference here in Belfast. Or it's all over the world, but we also have one in Belfast.
What's an interesting fact about yourself?
I once burnt cereal.
You burnt cereal?
Yep.
Holy! It's just milk and cereal.
I tried to make a warm bowl of Frosties, and I forgot to put the milk in before it went in the microwave.
Thank you, Abby and Dean, for that interview. Honestly, I didn't know you could burn cereal, but we learn something new every day. For now, though, we'd like to thank Andrew, Vincent, Claire, Abby, Jack, Stephen, Killen, and James for all making today possible and giving up their time to have this event happen. On top of that, thanks to both Craig and Daniel for their workshop, and Dean for doing today's interview. And on top of that, thanks Abby for doing your first interview. It was spot on. If you did really like this jam and you would like to sign up for next month's, you can. And the tickets are out now. The Eventbrite link will be posted out to those who have already gotten an email, and it will be posted in the chat just after this broadcast has ended. Also in this month's chat should be a link to this month's feedback form. If you can, please fill it out. It's just a wee short form, and it gives us your thoughts on the activities and the jam today. We do love reading them, and we love to make sure we can make every jam perfect as possible. That's everything from us, though. Thank you for joining us today, and we hope to see you again in the future.